Video will help you with the homework in Chapter Section B on properties like square root 3 times square root 3. You get the number under the radical, namely 3, back again. Today we're going to explore a few other operations, like for example multiplying, and then we'll look at dividing and adding and subtracting. If I take two radicals, well, these will actually be integers eventually, but right now they look like radicals. If I take two radicals and multiply them together, the thing we want to find out is that equal to the square root of 36 if I would just simply multiply them together? Let's check by dealing with each radical separately. The square root of 4 is 2. The square root of 9 is 3. And 2 times 3 gives me 6. So the left-hand side of this equation is 6. What about the right-hand side? Well, the square root of 36 is also equal to 6. So in this case, it works. 4 times square root of 4 times the square root of 9 is going to be the exact same answer as the square root of 36. So we can get rid of the question mark, and that is true. What about dividing? Let's use some similar numbers and take the square root of 36 and divide it by the square root of 4. So we want to find out whether or not that's the same as dividing 36 by 4 first and then taking the square root. So let's again check each side of the equation. We're first asking, are these equal to each other? Square root of 36 is 6. Square root of 4 is 2, and 6 divided by 2 is equal to 3. So the left-hand side of the equation is 3. On the right-hand side, we do the inside of the radical first. 36 divided by 4 is 9, and then we have to take the square root of 9, and the square root of 9 is 3. So indeed, 3 is equal to 3. So this one works as well. Erase the question mark because that one is also true. So multiplication, radicals can be multiplied together, and for division, the parts of the radicals can first be divided, 36 divided by 4, before I take the radical. Let's look at adding and subtracting next. If I go back to the square root of 4 and instead of multiplying it, add it to the square root of 9, is that going to be equal to the same thing as the square root of 13? So let's do our check again. Left-hand side is equal to 2 plus 3. That's equal to 5. The right-hand side, is the square root of 13 equal to 5? Well, the square root of 13 is going to be a big long decimal. I don't actually have to find out what it is because I know that the square root of 25 is 5. The square root of 16 is 4. If I write this out, the square root of 25 would give me 5. And the square root of 16 gives me 4. So 13 has to be even less than 4. So definitely 5 is not equal to whatever the square root of 13 is going to be. So in this case, this does not work. Watch out for that one. It's very tempting to want to add radicals together. When we look at adding radicals, we're going to have to remember that I can't just add the numbers together under the radical sign, even though I can do it with multiplication. So what do you think about subtraction? Be useful if you tried this one first yourself. Good practice. So once I've written it out, why don't you pause the video and see if you can figure out whether that is equal to the square root of 5. Maybe based on the results we already have, you have a hypothesis, but give it a try. Okay, if we're going to do it together here now, then square root of 9 equals 3, and square root of 4 equals 2, so the left-hand side equals 1. On the right-hand side, is the square root of 5 equal to 1? No. We know that the square root of 4 is equal to 2. So the square root of 5 is going to be a little bit bigger than 2. So we can say this is definitely not equal to square root 5. And we can change this question mark to a non-equality. Those two things are not equal. Now what we've done here is not enough for a proof. In mathematics, if I wanted to prove you can always multiply radicals together, I need more than one example. But I'm going to assure you that it is true and you don't have to worry about proving it today. We're going to write a general statement now after these examples that if I multiply some radical, and since I don't want to put a particular number in there, I'll just put an A. If I multiply some radical by another radical, the answer will be the same as if I first multiplied the radicals, the numbers under the radical together, and then square root it. Okay, so that's one of the properties of radicals, that if you multiply them together, you can multiply the numbers first and then take the square root. The same thing goes for division. That square root a divided by square root b is going to be the same as the square root of a divided by b. Okay, the other properties we tried are not true, so we'll leave it at that. These are two important properties of radicals. Okay, where can we use these in example problems, or what kinds of things will you be asked to do? I'm going to give you some examples from section B.1. We'll start with something fairly simple. If we do square root 3 times square root 2, that will be equal to square root 6. That's as far as you go. That's all we can show. Now we could put this into a decimal, but generally with radicals we leave them in their exact form, because as soon as I write down a long decimal, I have to round it off somewhere. So I'll leave it in the exact form. Okay, another example. If I do 2 square root 5 times 3 square root 2, I can combine two things. One, because this is all multiplication, I can rearrange it and multiply 2 times 3, and then take that result and multiply it by square root 5 times square root 2. So 2 times 3 gives me 6, and square root 5 times square root 2 equals square root 10. Make sure that you always keep separate the whole numbers and the radical part. Things that were under a radical sign here stay under the radical sign here on the right hand side, and things that were whole numbers stay on the outside as whole numbers. Put lines between examples. Okay, next example uses division. If I take the square root of 32 and divide it by the square root of 2, both of those create long decimals. They don't go to integers. But if I use the property of radicals in that I can divide the numbers first, 32 divided by 2, then I get the square root of 16. 32 divided by 2 is 16, and the square root of 16 is 4. So that does end up with an integer answer if I use that property of radicals. And here's one more example. The square root of 12 divided by 2 square root 3. I can ignore the whole number here on the denominator, the 2, and first divide square root of 12 divided by 3. So I should have made this square root sign a little bit bigger. And then take that answer. Let me write that again. Need a little bit more room because I still need the fraction over here. So I have 1 over 2 in whole numbers. I put a 1 on the top because there is no part of fraction here, so I can just say I'm multiplying by 1. That'll give me square root 12 back again. So let's put the 1 on top and the 2 on the bottom, and the radical part, 12 divided by 3, beside it. 1/2 stays 1/2. 12 divided by 3 is the square root of 4. So I get 1/2 times the square root of 4. And the square root of 4 is 2. So in the end, I have 1/2 times 2. Well, 2 1/2, or if I do official fractions and put this 2 over 1, and then do 1 times 2 is 2, and 2 times 2, this gives me 2 over 2, or equal to 1. Okay, so something as complicated looking as this can actually be equal to 1 if we use all the properties of radicals. You're almost ready to do the homework in B.1. There's one special type of question that I'd like to show you next. You might be asked to write a radical in a certain form. This here means that k is some integer that you're going to find out. It's some whole number. And square root 2 is the radical part. So I already know that I'm going to convert this into something that has a radical 2 and a part that comes outside the radical. How we do that is we look for perfect squares. If I look at the number 32 and start factoring it, of course I get 1 times 32, but that's not so interesting. If I take 2, because that's the radical part I'm going to be, and see what 2 times something gives me at 32, then I find out that that number is 16. So 2 times 16 gives me 32. 16 is what we call a square number. It's important in this kind of thing to have square numbers pretty much memorized. Let's list them for a minute. We've got 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. Can you keep going on your own? Even if I would write them down here. At least to 100 you should have square numbers memorized. Some of you want to memorize them even farther. So 2 times 16, 16 is a square number. That means if I take the square root of 32, I can split it up into the square root of 2 times the square root of 16, using that property of radicals backwards, that if I have a number, I can split it up into its factors. That can also be written as square root 2 times square root 16, and then I get square root 2 is unchangeable because that's an irrational number, but square root 16 is going to be 4. So I get square root 2 times 4. Now to write this in proper format, we always put the whole number or the integer first, and we put the radical bit, the root bit, second. So now I have it in this form where k is equal to 4, and there's the radical 2 that I had wanted. So that's your final answer in these kinds of questions. That's enough to finish B.1. If you're ready to go on to B.2, you're going to be doing that kind of task, splitting up a radical into a smaller form without the extra help knowing which radical bit is going to come out. So you might be given something like square root 12 and you have to write it in simplest radical form. Simplest radical form means take all the perfect squares out of the bracket so that you end up with the smallest possible number in the radical part. And to do that, we have to look for square number factors. So you have to remember your factoring from way back when and see, do any of these numbers, any of these square numbers go into 12? Well, 12 is quite small, so it's not so hard to do. Can start here. 9 doesn't go into 12, but 4 does. So I'm going to write square root 12 as 4, put the square number first. That'll make the simplifying easier. I'm going to write it as square root 4 times square root 3. Square root 4 is 2. Write them as separate radicals first to show you all the steps. Then square root 4 is equal to 2, and square root 3 is an irrational number that stays like that. So square root 12 in simplest radical form is the same as 2 square root 3. At any time, if you want to check if your answer is actually equal to the original thing, you can check both in your calculator. Take the square root of 12 and see what decimal it comes up with, and then multiply 2 times the square root of 3 and see if you get the same decimal. In this case you will, and if you have the right answer, you should always get the same decimal equivalent in your calculator. Okay, this next example is missing part of it. Square root 2 we wouldn't be able to simplify any further, but this was supposed to be square root 28. So again, with square root 28, our first step is to look for a square number that goes into 28. 28 is, maybe you've seen it already, is 4 times 7. So I'm going to change this to square root of 4 times square root of 7. The square root of 4 is the same as 2. And the square root of 7 is a prime number that doesn't have any more factors. So it has to stay under the square root sign. And that's the answer. Dividing works the same way, but of course we'll have some fractions here and that can be a little tricky, so I'll show you one example with dividing as well. Square root of 11 over 25 is the same thing as the square root of 11 over the square root of 25, so I can deal with the radical parts separately. Square root of 11 is a prime number, so there's no square numbers that are going to go into that, but 25 of course is a square number itself, so it's going to become an integer. So square root of 11 I have to keep, but square root of 25 is 5. Could leave it like that. Generally with radicals we don't want to have fractions as well with mixed radicals, so the more common way of writing this is to take the dividing by 5 as a fraction 1/5, because dividing by 5 is the same as multiplying by 1/5, and then multiply that by the radical part. So I kind of still have a number out here, except this time it's not a whole number, it's a fraction, it's a rational number, and I'm multiplying that by the radical part. And that's the answer. Okay, you're ready to do section B.1 and B.2. Good luck.